morning, good afternoon, or good evening. Wherever you are in the world, welcome and thank you for joining us. My name is Carl Anthony, and this is AutoVision News Radio Live at AutoSens and InCabin Europe 2024. We are with Dr. Gregor Sievers, Product Manager and Group Lead in the Engineering Services Department at dSPACE. Now, Dr. Sievers, his work focuses on the validation of systems autonomous driving, especially vision space systems. In 2016, he received his PhD in electrical engineering from Bielefeld University in Germany for his work on design space exploration of tightly coupled multiprocessors. Dr. Sievers, welcome. Good to see
Hi.
you, friend.
Yeah, nice for having me.
So, what inspired you to study electrical engineering for your PhD? Just reading your bio, I'm very intrigued, friend.
Yeah, good question. Yeah, I mean, I was always into like technical details and interested in electronics.
Sure.
So I was happy to be able to just do this for the bachelor.
Of course.
And then, I got the opportunity to, after my master's degree, to start with a PhD and also work with a great team on a quite exciting topic. So, really going into the details and really, implementing things here and really researching on some new stuff here.
I wanted to, reading that in your bio, it very much intrigued me. So congratulations on your PhD.
Thanks.
For a job well done and for getting through all your studies. We're here today to talk about digital homologation. So let's start there. What is digital homologation? What does that mean?
Yeah, maybe let's start with homologation.
Sure.
Yeah. So, as maybe not everybody knows about that. So, homologation is a process of an automotive OEM, automotive car manufacturer, to get the certification. Depending on the country, the process is different, but to get the certification to be allowed to sell the car.
Yes.
Yeah. So to prove that everything is functional, everything is due to the regulations. And this is a quite extensive process, and to make it even worse, it's different in different countries,
Yes.
So, for instance, in the US, it's totally different than in Europe.
Yes.
So the OEMs have a lot of experience in that, but the more software functions and the more sensors you have, the more challenges you have. So typically, in the traditional homologation, you do a lot of test drives on a test track or field tests on the road with some prototype vehicles, but this is getting more and more, and this is getting more and more expensive. So digital homologation now means that you start with the homologation process earlier, and you start with that by doing cloud-based simulation, cloud-based testing, or also lab-based testing. Yeah, and as you just said, the focus of today is the lab-based testing and the lab-based homologation. Yeah.
So with that good overview, let's take it now from the dSPACE perspective. So why is dSPACE promoting lab-based testing for digital homologation?
Yeah, I mean, obviously because so we now have the first European OEMs who are starting this process. Yeah, and there are a lot of different key aspects. We have a lot of regulation and a lot of also gremium work, and in different organizations due to that, and we are also participating, and we see that our traditional test-based products that we have in the cloud and also in the lab now can be used, and the use case can be extended to the digital homologation, and we are now going, as I said, the first steps with the first customers, and we have also learned now that you have to involve everybody. So not only the OEM, but you have to include the sensor suppliers, the tier 2s, all the tool chain. Yeah. So for instance, our own software is ISO 26262 compliant now, which is helping the OEMs in their own ISO certification process. So there are a lot of different components, and talking here at AutoSens about that topic, because only as an industry we can be successful here. Yeah, and we can be faster in the homologation process, and be faster to bring more sophisticated driving functions on the street.
Right. When it comes to level 3, what types of sensors do you see for level 3 applications? And then further to that, how do you simulate those?
So we definitely see cameras. Yeah. So cameras are cheap. They are widely used. So today we see 5 to 11, 12, 14 cameras in typical level 3 systems.
Sure.
and for sure in addition radars. And the big question is how many radars and what are the capabilities of the radar sensors. Yeah.
Sure.
So we have like lower end or standard radars. We have high fidelity 4D radars. This is a big topic here, and for sure we also have a LiDAR sensor. Some believe as a main sensor, some believe just as a backup. So open question, at least for me.
Right.
But in addition, we also have the ultrasonic sensor, especially for the parking. Yeah, if you have autonomous parking, or if your car is just in a parking garage, just parking by itself.
Sure.
So for this type of application, typically most companies will still rely on the ultrasonic sensor, and will rely, in my opinion. So you see, we have a lot of different sensors, and to make it even more complex, we have a lot of different test methodologies on different levels. Yeah, so
Sure.
we can do the testing and the simulation, and based on that also the homologation on the interface level, so on the CAN or Ethernet, for instance. Yeah,
Sure.
which dSPACE is doing for 25 or 30 years now.
Right.
But we can also do it on the raw data level, so having much higher data rates and raw data, but we can also do over-the-air testing, and we can also do a mix of that. So this means we have solutions for radar over the air. We can combine it with the raw data for the camera, and maybe with the REST bus simulation for the ultrasonic. So depending on the customer's use case, so the most important question I always ask is, what do you want to test and how?
Right.
Yeah, because depending on the answer on this question, every test methodology has advantages and disadvantages. Yeah, so it really depends on how you want to test,
Sure.
and what are your requirements.
Sure. Synchronization.
Yeah.
How important is synchronization for all of these simulated sensors?
Yeah.
And then how do you achieve that?
Yeah. So we are discussing this since years. Yeah, since 10 years, customers are asking, "Hey, yeah, how about synchronization?" And
Yes.
to be honest, during all the years, our solutions just have been good enough, and we have not to do any special tweaking. It was just working, and everybody was happy. And
Right.
for sure, we had the discussions every second week, but like it was, everything was fine. But now we have more sophisticated ECUs, so driving functions, and more safety and security checks. So now we really see that synchronization and also latency of the simulated sensors and of the test system is getting more and more important. And here at AutoSens, we at dSPACE booth also showing a joint demo with Mobileye, where we simulate camera sensors especially. So especially the synchronization is really a topic, because I mean, what's happening that if the synchronization is not good enough, then the driving functions just fail. So some special test. I mean, in a real car, you have to prove that everything is fully functional. Yeah, if you're driving autonomously and all the cameras fail, I mean, the car has to notice that and has to stop. So this means the more sophisticated these functions are, the better the synchronization is. And how do we achieve that? As I said, there are a lot of different ways how to simulate.
Sure.
And depending on the ECU requirements, on the customer requirements, we have different solutions. I always say we have a toolbox, and depending on the use, so there's not a single solution. Yes, but depending on the requirements, we can choose and mix and match.
That makes sense.
And we see that it's really a challenge, that you need more and more compute power for that. Yeah.
Yes.
So if you're just not fast enough, the test system is failing. But also it depends also on the hardware software co-design, and really to make sure that each and every component in the test system is really fitting the requirements.
Right. Dr. Sievers, I want to thank you for being with us and for sharing your PhD journey, for one at the beginning, but just giving your insights on level 3 and then this topic of synchronization. So from all of us here at AutoSens and InCabin, I want to wish you a great rest of the show. Safe travels home when everything concludes in Barcelona. And I look forward to being able to do this again sometime soon, my friend.
Yeah, thanks for having me.
More to come from AutoSens and InCabin Europe 2024 from the Fira de Barcelona alongside Dr. Gregor Sievers. I'm Carl Anthony, AutoVision News Radio.